Hi there, folks. This is the Practice Chapter 3 test, and as always, I am the amazing Mr. Jansen. So away we go. If we look at this first one, it's just asking us to solve by graphing. So whenever we're solving a system of equations by graphing, all we're going to do is graph it and find out where these two things intersect. So this first one has a y-intercept of -4 and a slope of 2. Just up 2 over 1, up 2 over 1. Draw the best line that I can. And remember, when you're graphing to solve these things, we want it to be as accurate as possible. The next one, we've got a y-intercept of 1 and a slope of -3. That's down 3 over 1, down 3 over 1. Once again, we draw the best line that we can draw. And then we just see where these two things intersect. These two intersect right here, which is the ordered pair 1, -2. So our solution is 1, -2. In other words, that's saying that our x value is 1 and our y value is -2. And that's it. Taking a look at the next one, asks us to solve this by substitution. And really, this is set up really nicely for substitution. It's already telling us that y equals this whole thing right here. So I'm going to plug that in for y in my second equation. So my second equation was 3x plus 2y equals 1. But instead of y, I'm going to plug in what y is equal to, which is the 3 minus 2x. And now I'm just going to simplify this and solve for x. So I distribute the 2. I end up with a 3x plus 6 minus 4x equals 1. I combine some like terms. That's going to give me a -x plus 6 equals 1. I subtract that 6 from each side. So I find out that -x equals a -5. And then I divide each side by the -1. So I find out that x equals a +5. But I'm not finished yet. Remember, I have to find y as well. So I have to plug this x value back in. So I get 3 minus 2 times x, which is the 5. So that's 3 minus 10, which is a -7. So my y value is a -7. My x value is a 5. So that's the ordered pair of 5, -7. And again, we write it as an ordered pair because it's a nice, succinct way of expressing x and y together. If I look at the next one, I'm going to solve this by elimination. So I need additive inverses in front of one of my variables. And this one's already set up for it. I have additive inverses in front of my y value, so I'm just going to add these two together. When I do that, I end up with a 5x equals 25. I divide each side by 5, and I find out that x equals a 5. But now, once again, I'm not finished. I've got to plug this back in, so I'm going to plug it into the first one. I've got 2 times 5 plus y equals 5. And now I just have to simplify this and solve for y. That gives me a 10 plus y equals 5. I've got to subtract the 10 from each side. So I find out that y equals a -5. And then the last thing I'm doing, I'm going to write this as an ordered pair, just because that's a really nice way of writing it. It's 5, -5. In other words, x equals this, y equals this. And that's it. Okay? If I look at the next couple, we're solving by the method of our choice. So we're going to look at this and decide, is substitution or elimination the best way to go here? For this first one, I would probably use elimination for this one. I've got positive and negatives in the right places here. So I'm going to eliminate x. I'm going to multiply each side by 2 on this second equation. And when I do that, let me rewrite the first equation was this guy, the 2x plus 4y equals 6. And now that second equation, when I multiply it through by the 2, gives me a -2x minus 4y equals a -6. And now I add these together. And what happens is when I do the 2x plus a -2x, that's 0. But now 4y plus a -4y is also 0. So both variables kind of eliminate themselves, which is fine. That can happen. And now on the other side, I add these together. I also get a 0. And this is why it's important to write this out. There's two special cases that can happen here. When I get a true statement, which is what I have, 0 equals 0, I say that this is infinite solutions because there are infinitely many solutions to this particular example. Okay? And keep in mind, keep this in the back of your head here, if I end up with a statement that looks more like this, if I end up with something like 0 equals a -5, well, that's false, so that one would be no solution. Okay? So just be aware of that other special case that can occur here. If I look at the next one, I'm going to solve this one by substitution. Since I have y plus 2x equals 6, this one's really easy to solve for y. I subtract the 2x from each side. And the reason I'm avoiding elimination is because it's not even set up for elimination. Okay? It's set up nicely for substitution. For elimination, I'd have to rearrange things to make sure that x and y are lined up because they're not right now. So now I know that y equals this thing. So now I'm going to plug that in for y in my other equation. So that's a 3x minus 2 times y, which is the negative 2x plus 6, equals 16. And now I'm just going to simplify. I've got to distribute that negative 2. So I find out that 3x plus 4x minus 12 equals 16. I combine like terms. That's a 7x minus 12 equals 16. I'm going to add that 12 to each side. So when I do that, I find out that 7x equals a 28. I divide each side by 7. So I find out that x equals 4. But once again, I'm not finished yet. I have to come back over here and plug that in to find y. And since I already have an equation that says y equals, I'm going to plug it in right here. Negative 2 times 4 plus 6. That's a negative 8 plus 6. So I find out the y equals a negative 2. All right? And then the last thing I do, I've been doing it with all of these, is I write it as an ordered pair. 4, negative 2. It's a nice, succinct way of writing my answer. Take a look at number 6. If I look at number 6, once again, method of my choice. When I look at this, I see that y is already solved for not only in one equation, but in the other equation as well. So I'm going to use substitution. So if y equals this, I'm going to plug that in for my y value right here. So my new equation is going to look like this. Negative 3x plus 1 equals the x minus 7. I plugged that first y value in for the second y value. And now I just want to simplify this. Always deal with the variables first. So I'm going to add the 3x to each side. So I get 1 equals a 4x minus 7. And now from here, it's easy to decide what to do. I've got to add the 7 to each side. I know I wrote an 8 like a crazy person, but I'm not crazy. There's the 8 I was thinking of. And now I divide each side by the 4. So I find out that x equals 2. Okay? Once again, I'm still not finished. I have to plug this in. I'm going to plug it into the second one. So I've got y equals 2 minus 7, so y equals a negative 5. Done and done. There it is as an ordered pair. If I look at the next one, when I look at this and I think about solving for x and y, maybe that doesn't appeal to me, or maybe it does. I'll do this one by elimination, although solving for y in the first equation is a great idea as well. But if I'm doing this through elimination, I have to eliminate x or y here. I'll eliminate the x values just because they're out front. So to eliminate x, I'm going to have to, essentially, really, it's like getting common denominators. Between a 6 and an 8, the common denominator is 24. So I'm going to multiply the first equation by 4, and I'm going to multiply the second equation by a negative 3. Because I want them to be the same, but I want them to be the opposite. Okay, I want a 24 in one and a negative 24 in the other. So when I multiply that first equation by 4, I get a 24x plus 12y equals 24. When I multiply the second equation by a negative 3, that's a negative 24x minus 15y equals a negative 36. And now I add them up. The x's eliminate. The y values, I'm left with a negative 3y. Over here, I'm left with a negative 12. And now I divide each side by the negative 3. So I find out that y equals a 4. But once again, I'm not done. I have to finish this thing by plugging it back in. So I'm going to plug it into this first one. 6x plus 3 times a 4 equals 6. That's a 6x plus 12 equals 6. I subtract the 12 from each side. So I find out that 6x equals a negative 6. And then I divide by the 6. So I can find out that x equals a negative 1. And then once again, I write it as an ordered pair. Just a nice, succinct way of expressing this. Okay? In number 8, we have to solve it using all 3 methods. So to do this, I'm going to start with graphing. For graphing this thing, I want each of these to be in the same format. Really, this first one looks okay. It's already in y equals mx plus b. That's easy to graph. The second one, I can either put 0 in for x and find y, and then put a 0 in for y and find x, and do the intercepts. That's an okay way to go. And if you do that, if you plug a 0 in for y, you find out that x equals 1. And then if you do the same thing and plug a 0 in for x, you'd have to multiply each side by 2, so you'd find out that y equals a negative 2. That would be one way to go. Or you can rearrange this equation. If you rearrange the equation, you'll find out that y equals, that's going to be a 2x minus 2. All right? Either one of those is acceptable. And to get to there, I just added the x to each side and then multiplied each side by 2. All right? So now I'm just going to graph these. I've got a y-intercept of 3 for the first one and a slope of negative 2. Which looks like this. And once again, I want to graph this as accurately as possible. I'm going to do my best, which that wasn't good enough, so I'm going to try again. That is better, but still not great. That's the one I'm looking for. Look at how beautiful that is. I'm just going to admire that for a moment. Okay, moment's over. The next one, if I do the x-intercepts and the y-intercept, the x-intercept of 1 and the y-intercept of -2, or I can think of it as starting at -2 and then up 2 over 1, up 2 over 1. Okay? Either way, I get the same graph, and I graph it with as much accuracy as possible. And when I look at this thing, I can't tell exactly where this is, all right? But I can tell that my x value is between 1 and 2. It looks like closer to 1 than it is to 2. And I can tell that my y value is somewhere between 0 and 1, so some kind of fraction. And that's very telling when I go to solve this in a couple other ways. I can't tell exactly where it is, but I have a general idea, all right? If I do elimination next, just because it's written here, what I want to do is I want to line everything up completely. Okay, so that first equation, I had the y equals a -2x plus 3. I would probably add the 2x to each side. Okay, and that would give me a 2x plus y equals 3. Now that one's kind of in my standard form. The next one, this guy right here, the -x plus 1/2 y equals a -1. That's pretty much in my standard form, but don't deal with fractions when you're doing this. Multiply each side by 2. Make things much easier on yourself. That's going to give me a -2x plus y equals a -2. Okay? Now when I write these things one right underneath another, something magical happens. I already have additive inverses in front of the x. Okay? And even though I wasn't trying to do that, I was just trying to simplify these and organize them in a nice way, it does make it easier. Even if I don't have additive inverses here, it's much easier to get them once it's organized in this fashion. Okay? So since I do have additive inverses, I'm going to add them up. The x's eliminate. I get 2y equals a +1. I divide each side by a 2, and I find out that y equals 1/2. But of course, I'm not finished yet. I have to plug that back in to finish solving this for x. And it doesn't matter which of these I plug it into. I'd maybe choose this one, so I have 2 times x plus y, which is the 1/2, equals a 3. And now from here, you can subtract that 1/2 from each side. But again, if you don't feel like dealing with fractions, don't. Multiply everything by 2. And watch what happens. 4x plus 1 equals 6. That's an equation that any of us can solve. I subtract the 1 from each side. So I find out that 4x equals a 5. I divide each side by 4. And really, that's easier than dealing with getting common denominators. It really is. Just multiply through and get rid of the fraction. And now I've got an x value of 5/4 and a y value 1/2. If I look back at my graph, that seems to make sense. I've got an x value that's just over the value of 1. 5/4 is 1 1/4. And I've got a y value that's between 0 and 1, 1/2. Okay? So really, this seems to match what I have on my graph. Let's check it with substitution just to make sure.